Now, talking about the minimum and maximum of a point, we can quickly study a function of y is equals to f of x as discussed, and we try to plot the graph of y equals to f of x in the xy plane. We are going to have something of this nature. So if we look at this carefully, we have a graph that looks like this. Carefully analyze it for understanding's sake. This is the x-axis. I hope everybody knows that. And that is the y-axis. So this is x and this is y. So we can just look into a curve and draw it to scale, but I don't think we need that now. We can just carefully draw a curve. Let's say that is a curve, and we have discussed before from our introduction to differentiation that we can have 2 points. The point here, we can actually say at a particular point here, let's call this point x1. We trace it up to the graph. You can say at this particular point, that is the point of x1. At this particular equivalent point is giving us y1. The same thing is applicable to this point, and say at x2, and it's giving us another point, which is y2. And as you can also see, you can also consider this point as x3. It's going to give us another point, and this point as y3. So my dear students, what I'm trying to say here is that at different points of the graph, we can have at different point of x values, we can have different answers for y. And if you work very carefully, this is the highest point of y, and we can say at this point the value of the curve is said to be maximum. So similarly, we can consider another point which is the lowest value. At s2, we have the value of y2 to be at this lowest point, which is called the minimum of the point. So basically, what I want you to understand in this slide is just to understand that, and if you also consider y3, you are going to see that as the graph is trying to approach the point of the maximum at x3. So now here, when we study carefully a graph of f of x, what we notice is that if we try to look at the rate at which y is changing with respect to s, already discussed, we call y prime, which we call the y dx, which we have discussed before, which is the same thing as writing it as f prime of x. So of f of x will definitely give us the change in y with respect to s, which is also the same thing as slope. So similarly, we say at a particular point of x, we have a value for y. So whenever we try to find a slope, I hope students are following me. Whenever we try to find a slope of a graph, when we look for the slope of a graph, which is more or less, and set it equals to 0, and set it equal to 0. So at this point, we say the graph is at minimum and maximum. Already discussed slope of the graph from what we've studied before. We say the slope of the graph is just like for this kind of graph, for understanding's sake, is just like trying to draw a tangent. And if you look at the tangent on top of this, it's more or less like an horizontal line for the three of them, which is the tangent and the slope of this curve. So we say these values that you can see here, to get that is drawing a tangent on top of each of them. We have discussed this before. So what I'm just trying to say in a nutshell is that if we look at the slope of this graph, which is always changing y over changing x, which is even as y prime, or if you like, the way we've been writing it since then, we call the y by dx must always be equals to 0. So what we're saying is that to get maximum and minimum value, because we have a long way to go in this video, all we need to do is just to differentiate the function or find the slope of the function, and that will give us the point of maximum and what minimum. So the method we employ, we can quickly talk about the processes involved, or let's say the processes or the process of finding maximum and minimum of a curve, a quick one, before we go into examples. So if we do that very quickly, dear students, we can quickly say, if we have a function of y equals to f of x as discussed above, we can say to find maximum and minimum, just write form of writing, to find maximum and minimum point, all we do is just look for what we call the y dx of this, like what I've said earlier. It is the same thing as the y dx of that is differentiating y equals to f of x, which is going to give us f prime of x. I hope students remember this, and we set it equals to 0. So what I'm saying directly, my dear student, is to look at the graph, look for the x point. When you differentiate, after differentiating, you are going to get a particular solution for x. So when you get the particular solution for x, you now substitute that particular answer into the function you are given to get the equivalent value for y. So I hope students are getting this. So always keep it in mind that to find maximum or minimum point, the first thing you're going to do is to look for the differentiation, or what you call the slope of the graph. And after doing that, the next thing you're going to do is just to substitute the value. That is, if it is having a particular, for example, it can be a quadratic function which has 2 solutions. So you just actually substitute it back into the function, and you're going to get the point of maximum and minimum. So having said this, the next thing is to consider how to differentiate between maximum and minimum. I believe that is also very, very important. Now, the logic is, let me just keep it as a note that to check maybe the value of x, check the value of x for y value for maximum or minimum. What we do in mathematics and physics is to go for what we call a second derivative. And to keep that in note, we can write that to check, let's just write it down for reference sake, to check whether at a value of x, y is maximum or minimum, we use the second derivative check. So now the second derivative check we call in mathematics is just like saying what we call, you can see derivative of y is the y dx, which is as f prime of x. You can also write it as here when you say second derivative check, we write it in form of the 2y over the x squared. If you don't want to write it like that, you can also write it like saying y prime prime. Remember, y prime is the first one and y prime prime is the second one. So what I'm saying here is that whenever you want to check for the point of max or minimum, student can keep this in mind that you go for the second derivative check to confirm if it is maximum and minimum. And the logic under this confirmation is to also understand that if it is a maximum point, if the point is maximum, we can start from that. So if the point is maximum, what you do is this, guys, watch. Now, after double checking, after double differentiation, and you are having a positive value. So let me just write that and write it also. When the function of x is now being differentiated twice, and the answer is positive. Whenever you differentiate it 2 times and you have the answer being positive, that means y is minimum. So my dear student, what I'm saying is that we want to find maximum and minimum on point of a graph. We just differentiate that particular equation, then getting some values of x. After getting some values of x, we substitute it back to get the y values. Sometimes when you are looking for minimum, your answer can be maximum, and sometimes the students do complain and they don't know which is correct. Is it maximum or minimum? I said to do that in mathematics and physics, what we do is just to differentiate that function again. And when you differentiate 2 times, you can see f prime prime F prime means the y what from that is first derivative. So and when you make it double, or what we write as the square y over the x squared, is called the second derivative check, and this method is used to verify if it is a minimum value or maximum value. So if you differentiate twice and you have the answer of x to be positive, I mean y is minimum. But when you differentiate twice, the function of x twice, and the answer is negative, my dear student, you don't need to waste your time. I mean y value is maximum. So this is the method we use mostly in your mathematics class to actually get maximum point and minimum point. To carefully understand this, we can look into a simple example before I go to some other type of example which is needed, because this will be the end of the video on our differentiation basics. We move to integration in the next slide. So we are given y is equals to, we are taking example 3x squared, we have a plus 7x, we have a minus 4 is equals to 0. The examiners ask find maximum or minimum. So find the maximum slash the minimum. So from what we have just studied now, we don't need to rush ourselves, just keep it calm and simple. We said to find maximum or minimum, what we do is just to find the y prime, or what you call the y by dx. That's the first method. This is an algebra expression. This is going to give us 6x. I hope students can still remember, plus 7. Now, a constant will always give us 0. Already discussed that. So now, this is the first derivative check. And when we do that, we set our answer to be equals to 0. Remember, whenever you do that, set the answer to be equals to 0, then you are solving this equation. So on solving, we have, this is the equation I'm solving, my dear student. And on solving, we are going to have 6x is equals to negative 7. And here we can write as x is negative 7 by 6 will be the value of x, which we are now going to substitute back into the function. Now, we are going to substitute this x equals to negative 7 by 6 into this function and get the value of y. Now, the question is, the answer you are getting when you substitute, is it a minimum value or a maximum value? Then you can now check. So always keep that in mind. Now what you do now is, this is your first derivative. You add 6x plus 7. Now to check, you now differentiate again. You can call it the square y over the x squared. And when you differentiate 6x plus 7, or you call it y prime, y double prime, which I think is quite easy than this. Now you can now say, if you differentiate 6x plus 7, you're going to have 6. Now we can now check, is 6 positive or negative from here? 6 is positive, everybody knows, and that means that the answer I am going to get when I substitute this back to my equation here is going to give me the minimum value. I didn't pin after substitution, the answer was negative. The answer we're going to get will be the maximum value. So what we say here is just, therefore, right, the minimum value will now be, you substitute. Please don't forget to substitute. Y is equals to 3, you open your bracket, negative 7 by 6 all square plus 7, open the bracket, negative 7 by 6, and you have minus 4. I want you guys to finish this. You write your answer, and that is the question answer for that. So always keep that in mind, please, whenever you are doing minimum and maximum value inside the xy plane. Always have it at the back of your mind that second derivative check is important to know if the value is minimum or maximum. Then the question is, what is the maximum value of this point, of this question? So you can now write, in case the examiner asks for maximum value, you can write as, know that there is no absolute value that exists for x for which y is maximum. maximum. So always keep that in mind. That means we don't have a particular value, an exact value. So that means continue to rise till infinity. So these are logic you still learn more in your math class. You know, the basis was basically for physics, for us to understand our concept clearly as we move forward in our knowledge of physics. So let's take some good examples. If time permits, we take two so that we can actually know we are through with the basis, and we start integration in the next slide. So let's check the next one in the next slide. Fine. We have examples right in front of us, and the example here is this very good example. We have to find the minimum area of an isosceles triangle which can be inscribed in a circle of radius 6 cm. So we have to find the minimum value already discussed. All we need to just do here, my dear student, is also remember to draw a circle and put an isosceles triangle inside the circle. So let me take my circles to be that, and everybody knows how an isosceles triangle is going to be. So let me just go with a rough sketch and not an exact value. I will take that as the center of my circle, and from that place I can also decide to draw out the radius. Distance from the center to any part of the circle is going to give me the radius. I hope students still remember all these shorter things we have learned in early classes. So here is going to be the radius, which I want to assume to be, it was given to be 6. I'm not assuming it's an exact value. So the radius of this was 6 centimeter. I just draw to form any type of triangle the way I like it. So I'm trying to bring out my triangle diagram, not drawn to scale. Anyway, I can try and draw it to scale if I want, but all the same, let's try and get a better diagram for understanding's sake. So I'm trying to draw my isosceles triangle out, and as you can see, so let's say that's my triangle. So not to scale, as you can see. So distance from this center as a center is, don't forget, this center, we can call the center O, or whatever you like to call it from your mathematics knowledge. Remember, any length from the center to any part of the circumference is radius. So radius was 6. This side to this side, if I join, will also give me 6. And note, if I should join here to here, let me use red for clarification. If I should join this is not a radius. Rather, you call it height of a triangle from early classes. I hope students still remember that. So if we draw this part to this part, we have something like that. You can try to complete it. If you want to complete it with this height too, is allowed, but it is not necessary. But let us just follow your math knowledge for clear understanding. Now here, this is what we are talking about. Here to here is 6 centimeter. I hope students can see this. Here to here is also radius 6 centimeter. Here can be taken as height of triangle. I will just take it as x. So let's take this side here. We don't know. I will take everything from here to here. I will take it as L. The logic we learned from early classes will be perpendicular bisector. I hope you remember that from your maths class. So this is also going to be L. So now the question asks me to find the area of an isosceles triangle which can be inscribed in a circle, which I've tried to draw out, though this is part of mathematics which I am not supposed to be doing, but all the same, from your knowledge of math, area of a triangle should be half base times height. So fine, I'm not having an angle, and I don't want to use any complex formula that we are not going to get. So from here we can do direct substitution. Area will be equals to half, the base here is L plus L, that is 2L, times the height. I'm taking the height to be x. Now, very good. The isosceles triangle height, very good. This is very perfect. The isosceles triangle height, students should understand that it is from this point. You can see, I nearly make mistakes. So this point, here to here is x, here to here is 6. So the height here will be x plus 6. I hope students understand that. So here, if we expand this, 2 we get cancelled out. We have A, which is the area, will now be equals to L open bracket x plus 6. So from here we can see that we are having kind of two variables which I can have L. So what I needed here is the maximum or minimum area of an isosceles triangle. So base times height, I can actually try to set a relationship from here, a right angle triangle, and use my Pythagoras theorem This is 6, this is x, this is L. I hope students are still there. Now from there, I can now say, from here, I can say L square plus x square is equals to 6 square. Everybody should know that, Pythagoras Theorem. So what I'm trying to do here is I want to remove one variable here. So I can make L square a formula. I can say L square is equals to 36, because 6 squares are 36, minus x square. So L subject of relation will be giving me under root of 36 minus x square. So where I see L in my equation here, I can say A is equals to, I want to make it one variable before I actually differentiate. So A equals to L value are under root of 36, or square root of 36 minus x squared, then multiply by, I use dot, x plus 6. So this is the relationship of the area of an isosceles triangle in terms of what? In terms of the height. So now guys, what I need to calculate is the minimum area. So now we just discussed that at minimum, the y dx from our formula must be equals to 0. So in this case, I'm having a and x. So therefore, I can write this in this way by saying dA dx must be equals to 0. So let me differentiate this, and I'll use my product rule, because what is connecting these two is product. So u and v, you know the logic. We keep this the way it is, that is x plus 6. I hope students are getting it. We differentiate this from our chain rule. How do we differentiate 36 minus x squared? We said what is here to be u. Everybody knows if you have u, square root of u is the same thing as 1 over, so that is times 1 over 2 root. That is the logic, 2 root. You can't put u back, you have to bring the t back. Watch my video in sequence to understand all this. So you repeat that, that is 36 minus x squared, then multiply by 2. Oh, multiply by negative 2, because when you differentiate negative x squared, you have negative 2, multiply by negative 2, and we add it 2, that is plus. Keep the first one the way it is, that is root 36 minus x squared, then differentiate x plus 6. If you differentiate x plus 6, that will give you nothing but, that is 1. So I'm using product rule of differentiation to get that, and if I go by that, you can say the 2 get cancelled out here. The first way to get this, to reduce this is 2 get cancelled out. So here, don't forget this is a negative sign, and for your knowledge of mathematics, watch this LCM stuff. Anything times 1 will still give you what is there, so I don't need to waste time. Negative times this one will give us negative x. I hope students are getting that. Negative x squared, then we have minus 6x. So this will move up, we have that is a plus 36 minus x squared. You know, whatever we get, we must set it equals to 0. So please note that. So we have from here we can finish this, I believe. So therefore we can say this will give us negative 2x squared. I hope students are following this, plus 6x minus 36 is equals to 0. I can reduce it by dividing through by 2 or negative 2. I'm dividing each of them by negative 2's. This should give us x squared minus 3x minus 18 equals to 0. So here I have x plus, I'm factorizing x plus 6. It should be plus 18. I have x minus 3. I hope I am right with that. If I distribute negative sign to avoid errors, so we have negative x squared, very good. This negative here is what I use here, then this will go up, cancelling each other out. 36 minus x squared minus 2x squared, this is minus 6x, so that is where the issue is coming. Minus 6x plus 36, so this will give me x squared, then we have plus 3x, and we have minus 18. Very good, and this is the factorization. Very good, this is correct. So because 6 times negative 3 is at that, then this is this equals to 0. So we have two answers. X is equals to negative 6 or x is equals to 3 is the solution to this. So from there you can now say fine, you have two possible values, and what you do here is that you're actually talking about triangle, and inside the triangle you can't have a value of negative. So definitely what you are going to substitute, remember, to get the minimum value is going to be, you are going to substitute that to get the area. This is the relationship we set for area with triangle. Area is equals to L open bracket x plus 6. Now that x value is 3, area will now be equals to, we have O. This is the best relationship to just substitute directly, my dear students. You have this particular value is the area, this particular value that connects everything in terms of x. So we should just go for that instead of this, excuse me. So we should have under root of 36 minus x squared multiplied by x plus 6. So we have gotten x to be 3. So area will be equals to, you can now say 36 minus, I will do it directly because of time, 3 squares are 9. 36 minus 9 is 27, and 3 plus 6 and 9. This is the same thing as saying 9 root 27. Or if you like, you can reduce it, and that will give you 27 root 3 centimeters square. So which will be the minimum value of the area of an isosceles triangle. So I hope students understand this, and if you do not understand, you can carefully watch my other videos on how to differentiate, carefully study them in series, in pattern, in sequence, to get everything as the way it should be done. So guys, I think I should stop here. So maybe I will try as much as possible to do some example more, and maybe rate of change some other time. So my next video will be on integration, so that because we have a long way to go. See you guys. I hope you understand this. You can also check, please excuse me, you can as well check if the value is minimum truly. What do? You differentiate this once again. So if you differentiate this particular value, this expression that we have here once again, and if the answer is positive, you know the logic. If it is positive, which will be positive, it is the minimum point, or if it is negative, it will be maximum. So that is how we do that in mathematics. See you guys soon. Bye for now.